All right, let's go ahead and run through a problem where I ask you to determine the derivative of a function by using the limit definition of derivative. I said that from the beginning of the semester that I was going to include this, and I'm going to. So let's go through a practice problem here. I'm going to set you up on my iPad. Take a look at my iPad here, and we'll go from there. So one of the things I want you to remember is that what this is the change in y over the change in x. The change in y value, the change in x value is you're taking an x value and then you're moving over h, and that change in x value is h. That's it. And the change in y is, well, you started at x and you moved over to x plus h. And that difference in y over the difference in x, and the limit as h goes to 0 of this getting smaller and smaller, smaller and narrower, approaches the actual definition of derivative that we had talked about earlier in the semester. So let's do this. Let's go through the process here. So if f of x is equal to 2x squared minus 5x plus 7, then the derivative of that using the limit definition is going to be equal. And again, I'm going to use the word limit, the symbol there of limit of as h goes to 0 the first time, and then I'm going to plug in smiley face along the way. But it's equal to f of x plus h, which means I need to plug x plus h everywhere there's an x in the function. So that means I get, what do I get? I get 2x plus h squared minus 5x plus h plus 7. And then I've got to subtract f of x. And I notice I didn't put parentheses around f of x plus h, but I do need it definitely on the x because every term needs to be changed. The sign of each term in the function needs to be changed by this minus sign that's in the function. This minus sign is going to be there every time. So parentheses around that last part will be a crucial part of making sure you handle that correctly. And that's going to be put over h. So I'm going to resort to the smiley face there. There's the limit as h goes to 0 of, all right, let's multiply out one step at a time and simplify things as we move along, okay? So I've got 2 times x squared plus 2xh plus h squared. Remember where that's coming from. That is x plus h times x plus h. You have to multiply that out, and that's what you end up with there. All right, 2 factor out front, and then let's distribute that minus 5. It's minus 5x minus 5h plus 7. And then we just change the signs of all of them inside the parentheses and get rid of the parentheses. And that's going to be over h. Okay, so notice before we distribute that 2, we can cancel out. We got a minus 7 and a plus 7, and we get a plus 5x and a minus 5x. And we got those other things left behind. That should be a 2x squared, shouldn't it? Yeah. All right, so we end up with smiley face, limit as h goes to 0. Multiply this out, 2x squared plus 4xh plus 2h squared minus 5h minus 2x squared. Keep track of things. You know, when you get things all crossing off and all this kind of stuff, you can lose track of things. So make sure you write it neatly and make sure it's clear over h. And now we notice they'll get that minus 2x squared and the plus 2x squared cancel, and everything less has an h in it. Everything else, all 3 of those terms have an h in it. So what I'm going to do is go ahead and factor out that h and use smiley face one more time. But factor out an h, that means we've got 4x left behind there, 2h minus 5 over h. And again, part of the reason why what we're doing with the limit, we're going to plug h we're going to plug 0 in for h at some point, and the h is still in the denominator, so that is not, you can't do that yet. But once it cancels, which we're doing right here, now you can actually plug 0 in for h, and that's what we're setting it up for. We keep the limit coming down the side until the denominator goes away, and then we can plug in 0 in for h, and that means we got this scenario left. And that ends up giving us, as h goes to 0, we end up with, now I'm plugging 0 in for h, so I no longer need to use the LIM in front. Okay, I'm plugging in 0. So I've got 4x plus 2 times 0 minus 5, which is 4x minus 5. And you know, it would be wise for you to check from the very beginning and just make sure that you see that f prime of x is going to be 4x minus 5. That can be a good starting point to see, make sure you don't make a mistake along the way or something like that. But that is the final solution of the situation. All right? And that is using the limit definition. You'll see one of those on the final exam. Thank you, and I will move on to a couple other recordings coming up very shortly.